Okay, long run profit maximization for the monopolist. Okay, a recapitulation. So, in the long run, what the monopolist is going to do is to set marginal revenue equal to long run marginal cost. That determines the quantity of output that the monopolist will produce. So looking at the graph here, price axis, quantity axis, the market demand curve is the same as the monopolist's average revenue curve. The monopolist is the market. And here's their marginal revenue curve right here. Okay, so marginal revenue, average revenue. Okay, marginal revenue, same vertical intercept as average revenue, but twice as steep. Okay, so marginal revenue intersects long run marginal cost right here. So this is the monopoly's quantity of output. They go up to the demand curve to find the monopoly price. The monopoly price is greater than marginal cost, which, as we've said before, indicates the amount that there is allocational efficiency, inefficiency, allocational inefficiency. If there were to be allocational efficiency, price would equal marginal cost like it does under conditions of perfect competition. So in the long run, the monopolist is allocationally inefficient. Price exceeds average cost. So the green dotted rectangle indicates the amount of positive economic profit being earned by this monopolist. Keep in mind that means an above normal rate of return on capital. This is the quantity of output they're producing. Okay, this is the quantity they would need to produce in this particular case to be at the minimum point of the long run average cost curve. So what we see in this graph here is a depiction of positive economic profit, which economists think of as a type of inefficiency. Okay. You also see the quantity of output chosen by the monopolist is not the same as the quantity at the minimum point of the long run average cost curve, thereby indicating engineering inefficiency. Okay. In addition, as I said before, price exceeds marginal cost, so there's allocational inefficiency. Now, positive profits under conditions of perfect competition would attract new entry. But under monopoly, new entry is blocked for a variety of reasons. Okay, one of those reasons could be legal barriers, another could be ownership rights. Okay, nobody else can get into this industry, right? So these positive profits perpetuate indefinitely, as does the engineering inefficiency. Okay, there's no process of new entry at work here, like there was in perfect competition. In perfect competition, if the typical firm earns positive profit, that attracts new entry. Here in the case of monopoly, you don't get new entry. So these positive economic profits perpetuate, as does the engineering inefficiency. In addition, since the monopolist doesn't face the heat and pressure of competition either presently or as a process of new entry occurs, okay, monopolist is insulated from that type of competition. So there's going to be a tendency for costs to rise above their true minimum level. So think of this entire long-run average cost curve here as shifting upward over time due to X inefficiency. Recall Harvey Liebenstein. He was the pioneer of that concept. Without a lot of competition, firms feel insulated from competition. They could well decide to take a measure or some degree of their positive economic profits in the form of managerial slack, allowing the entire cost structure here to rise above its minimum level. So, profit max for the monopolists set marginal revenue equal to marginal cost. That occurs right here. But there is a second order condition to the profit maximization rule. So the firm not only sets marginal revenue equal to marginal cost, it has to be where the slope of marginal cost is greater than the slope of marginal revenue. Okay, so here the slope of long-run marginal cost is positive right here. Slope of marginal revenue is negative. So that's clearly a profit max, right? Unlike perfect competition, though, under conditions of monopoly, marginal revenue is negatively sloped here, right? Under conditions of perfect competition, the perfect competitor faced the demand curve for his or her individual product that the slope was effectively zero. So in order for the second order condition to be fulfilled, marginal cost had to be rising. Under conditions of monopoly, the slope of marginal cost doesn't have to be positive for a profit max. It's merely a case where the slope of marginal cost has to exceed the slope of marginal revenue. So if both had negative slopes and long-run marginal cost had a slope of, let's say, negative 1/2, and the slope of marginal revenue was -2, well, -1/2 is greater than -2. Therefore, the slope of long-run marginal cost in that case would be greater than the slope of marginal revenue. We would have a profit max. But anyway, here's the rule. First order condition, set marginal revenue equal to marginal cost. Second order condition, slope of marginal cost has to be greater than the slope of marginal revenue. And that occurs right here. Okay, so marginal revenue in black, long-run marginal cost in blue, and long-run marginal cost here has positive slope, so the second order condition is obviously fulfilled here, right? In the case of natural monopoly, which we'll see in a little bit, well, in that case, the slope of long-run marginal cost is negative, but there's still ample opportunity for that slope to be greater than the slope of marginal revenue. So we'll see that in a minute. But this is profit max for the monopoly, and I recapitulated the basic inefficiency results, but this time giving you a graphical depiction of the inefficiency results of monopoly in the long run.